Alright, so let's start with the central limit theorem. So from before, we look at the variable which is the sample mean. So we're looking at that distribution, which is a sampling distribution. One parameter we look at here is by adjusting the sample size. So as the sample is small, you can see the distribution is kind of a little bit all over. Okay. Now, as you increase your sample size, it will start becoming more like a normal distribution. All right. So the application of that is this theorem. So you usually start with a random variable, which is normal, has a mean and a standard deviation. You're going to do some sampling. So you have a sample size and you're going to assume that it's large enough. Then what you're going to do is you can assume that the distribution of the sample mean is normal as well. It has a mean of which is the same as the mean of the random variable, but the standard deviation of the sample mean variable is going to be the standard deviation of the random variable x over square root of n, and n being the sample size. For most distribution, a sample size of 30 will be sufficient. Oh, there's a typo here. Okay, great. Moving on, let's look at an example. We just started covering that in methods, but anyway, here is a probability density function. Okay, it is. So when you anti-differentiate that over, first it's positive, and when you anti-differentiate that over the whole domain, it equals to 1. Now you need to find the probability that the average amount, so average, we're talking about the sample mean, contained in 25 randomly chosen cups will be more than 173. So here is our x random variable. Okay. Now we haven't covered that yet in methods, but you need to find the standard deviation and the expected value of the original hybrid function. So here is the expected value. You do the expected value, which is the mean or mu here. Then to move on to the variance, what we'll do is we need to find the expected value of x squared, evaluate that, and then we use the variance formula and we square root to find the standard deviation. So those two values of mu and sigma will be used to inform the sample mean variable as a normal distribution. Alright, we apply the central limit theorem. So the sample mean is going to be a normal distribution. The expected value is the same. With the standard deviation, you need to divide by the square root of 25, which is the sample size. We get a new standard deviation. We need to find the probability of the sample mean being greater than 173. Using the expected value and the standard deviation, we standardize it. Once it's standardized, you can use the CAS calculator. Oh, hang on. Yes, hang on. When you standardize on the CAS, it needs to be a standardized. The probability has to be less than before you enter it on the calculator. That is why they use the complementary. And they get the answer. Okay, we haven't covered that in methods yet, so just keep that in mind. Okay, now if you have a binomial random variable, so x is a binomial random variable, we have the parameters n and p, then the distribution of x is usually approximately normal, so we can determine the mean and the standard deviation using those formulas. Okay, those are kind of a preconditions. The idea is you want to have a large sample size. Okay, so let's look at an application as an example. So here, first we start with our binomial variable. X is the number of females in the sample. So X has a binomial distribution. We know N and we know P. Okay. We determine using the from the previous slide. We find the expected value being P. We find the variance and then the standard deviation. So that's P bracket 1 minus P over N. So we get the variance here. Now just be careful here is when it says what is the probability that the random sample of 100 people will contain less than 45% female. Now the 45% is a proportion. It's not a number, an absolute number of females. Okay, so that 45% is a 0.45. So we need to do a linear transformation with a scalar factor, which is or x variable over the sample size to turn it into a proportion as well. Okay, then we standardize that using our mu or mean and standard deviation, square root that. Probability of z is less than -1. You can probably do that by hand, but anyway, you use the CAS calculator and you have your answer. And that's pretty much it for 15E, and I'll see you next time.